continuing the whole idea way back when we started, we're talking about building a little goal tracking application. We've gone through a bunch of steps. Now we're starting to get into sort of the implementation kinds of things. Talked about object-oriented. Now we're going to actually take that a little deeper. We're going to talk about some software patterns as a way to really inform our object-oriented design and do some of this stuff in a best practices kind of approach. So just as a recap, we started out with our problem to solve, track some goals. We built requirements, we put together some use cases, we created a clickable demo. From there, we built a user experience, then we got into sort of the back end, flipped over there and went into the designing a database. Now getting into sort of the middle tier guts of the application, we started talking about general objects design. And now we're going to start looking at like code structure and stuff like that. So it's a step beyond just, putting a couple of core classes together. Now it's like, all right, how are we really going to build this thing? What kind of stuff we're going to need? And since we're going to do that, one of the things we want to do is look at patterns of software design. One, to speed our implementation, to not, reinvent the wheel, and possibly even to give us some ideas on how to implement and solve some of the problems we're going to have to solve. At a top level, it starts with, well, what is a software pattern? Pattern is, by definition, I'll just read that one for you. A pattern is a best practice or well-defined approach to solving a problem. It's, hey, it's been done before. If you take steps A, B, C, and D and you solve the problem, then, especially in computers, steps A, B, C, and D should solve it again. So, thus you have a pattern. Much like knitting patterns or anything else, if you follow it, you should get to where you need to be. This is awesome for new designers because they can, if you're sort of getting into software design, patterns are a way to quickly scale you up and sort of buttress your experience with some additional things, which would be these patterns. So there's problems that have already been solved by people, multiple times, probably way smarter than you are, especially when you're starting out. All of that experience combined gives you a best practice, a best approach. Hey, here's the way that you want to solve this problem. Thus, you have a pattern. The whole idea of software patterns originally came around, it floated around for a while, but it's like the genesis of it is a book called Design Patterns, Elements of Reusable Object-Oriented Software. This thing came out in the early 90s, so it's now, pushing almost 30 years old. It's often referred to as either the GOF pattern book or Gang of Four, because there were four authors that wrote it. And they were, at the time, those were they were the Steve Jobs, probably a bad example, but the Steve Jobses of software design. These are the guys that really were deep into developing object-oriented software. And this is, it's the early 90s, so object-oriented hasn't been around a long, long time. But these guys had done it a bunch, and they started to realize that, hey, as part of reusing objects, well, we can even reuse these things in a very general sense, thus a pattern. So it's not code, it's sort of like a guide on how to code. So there's a bunch of patterns out there. There's probably, 4 or 5 dozen patterns out there. If you go Google around, and I'll give you some examples of Googling a little bit later here. If you Google around, you can find a bunch of these. You can find examples of them. We're just going to cover in this one because of time, basically. We're going to limit it to, whatever this is, 10 patterns that are pretty common. They're called the strata, and these are the official names of them. Some you'll recognize, some you'll recognize them more once we start describing them. We're going to talk about strategy. We're going to talk MVC. Now MVC, I just want to mention that there is a lot of variations on a theme that have come out of that, like now MVVM, which is heavy in like the Microsoft world, and there's some other approaches similar to it. MVC is sort of the grandfather of them all. It's still, I think, probably, personally, I find it to be one of the best, just by the way that it keeps everything loosely connected. We'll talk about that a little more as we get to MVC. But then we've also got factories, iterators, flyweights, adapters, builders, singletons, commands, and interpreters. So we're going to go look at each of these one at a time and sort of how they work and what they solve. So strategy. A strategy, and this is a pattern, a strategy pattern is a way to do something. For example, a strategy would be to get from a hotel to the airport. Now, within that strategy, you could get there via car, via bus, by walking, teleporting, time travel, whatever. I mean, you could probably think of all kinds of different ways to do it. The way a strategy works is that you identify an algorithm that will be used. So it would be like, in this case, travel to airport. So it's the underlying goal. It's the underlying, hey, I'm trying to do something. It's the underlying function. So it could be stuff like send to printer. It could be store data, stuff like that. There's a whole lot of different things that you could use as a strategy. In this case, what you want to do with the strategy pattern is first you specify the signature. So it's going to be things like within a strategy, like for this case, if we're talking about travel to airport, well, your signature is going to be, well, how many travelers? Is there a method, that they've got? Like, is it by foot, by, car, something like that? And then in this case, we're going to return a time and a cost. So my strategy I'm looking at is I want to have a travel to airport strategy. I'm going to give it a number of travelers. I'm going to give it a basic method, and then it's going to kick back a time and a cost. And this is just to give you a hard example of what a strategy would be. You're going to bury the alternative implementation details into derived classes. So I may have like a master, let's say a route travel to airport. Well, I'd have a subchild that would be a subclass that would be, travel to airport by car. Another child maybe travel to airport by foot. So it ends up being, if you're familiar with it, ends up being sort of like an interface kind of approach. Because what you have is you have that parent class, in this case, travel to airport, the top level strategy gives you your interface. It gives you, your signature. It tells you what you're going to return. However, unlike an interface, you may have pieces of the strategy are actually in there, and normally you would. It's not going to be just a codeless parent. It's not going to be just some sort of abstract. You're going to have something up at the parent level that's going to be doing some of this work. And then within the derived classes, you're going to have the actual implementations of those. So for example, in the travel to airport, what you may do is you may have maybe let's say there's 4 steps to traveling to the airport. So maybe you've got to, you've got to go to the interstate, go to the parking lot or parking garage, find a parking spot, and go to the terminal. So in that case, that's your core steps. Well, depending on what you do, that you may be able to skip some steps. So you may have something where, in each of those cases at the implementation level, it's going to say, travel to interstate, travel to parking lot garage, find parking spot, go to the terminal. Well, if you're by foot, that implementation is going to skip a couple of those steps because you don't really need to go to the garage. You don't need to go to the parking lot. You just go basically, go to the terminal. And I'm really simplifying this, but the idea is that anybody that's using the strategy is going to just work off of that parent class. And then the implementation details are just, it's going to implement a specific instance, in this case would be like airport by car, airport by foot. These are often used for things like data interaction. So you may have save, you have an object where you have save, and you may have a data saver class that just takes some information and writes it out. Well, underneath the covers, you may implement it. Sometimes you may say, well, I really want to do the save to database, or another one you want to do, I want to do the save to file, save to memory cache. Those would be different, but that allows all the callers to couple to the interface. MVC. This one's used a lot and I think pretty well known. Basically, this is a complex strategy. It's for building a solution, a full solution, not just like solving a simple problem, but an entire solution, like software solution. MVC stands for model, view, controller. And that's the three aspects basically of your solution. You've got the view, which is what the user sees. You've got the model, which is on the back end, which is your data. And then your controller is how you move around between those two and how you move through the application. An MVC pattern, you start by identify the data you're going to be working with, which is the model. Then you identify the manipulations you need to do to the data. And that's going to be, probably in the controller, and it's going to help you create your controller, because from that you should be able to get the signatures for those manipulations, which is definitely the controller. And then you're going to identify the ways to display the results and gather input, which is the view. So this is typically the way you want to do MVC is in that order. You do the model. I'm sorry, not in that order. It's from the back to the front. So you do the model, you do the controller type pieces, and then you get to the view. And the reason you want to do that and not vice versa is that if you start with the data, then you move to the manipulations, then that whole time you're not really, you're not creating a view. You're not tying it to any kind of interface. You're doing it all within a vacuum. So there may even be no interface, or command line interface versus graphical interface. If you do it in the reverse situation, if you start from the view, then typically what happens is that view constricts you all the way back to the data, is that you've made too many design decisions before you should have. If you start from the data and work your way to the front, then that's more, it's natural then to make your design decisions when you need to do it, and not sooner, and not before you have, you're fully informed about the information you need to make those design decisions. Factory patterns. Factories are used fairly regularly if you're in the Java world. I know that J2EE, you'll see factories fairly regularly. If you use Hibernate, it uses it a lot. Seems like I've seen a couple of C# libraries and that we use them, but they slip my mind right now. What factory is exactly that. I mean, is what it would implies. It provides a way to build a family of objects. So like an auto factory could build a car or a bus or a truck. If you think in the real world kind of example, a food factory could build a sandwich or soup or dessert or things like that. So what you tackle at a factory pattern is you got to map out the platforms and the products. So it's basically, what are the factories? What are the things that I need to be working with? And then what are the products that I'm going to kick out? Describe you're going to describe a factory interface with a method for each product. So you're going to have a way to go in and basically do something simple. The interface would be like build or deploy or something like that. And then underneath the covers, you're going to have a method for each of the products. And in doing that, then you could do that way you could do build, build car or build bus or build truck. And then you're going to pick out from there, you're going to have a method that's basically going to build out that class and then kick it out as a result. You're going to define a factory derived class that encapsulates all the new references. And then you're going to remove the ability to call new and leave only the factory as an option. So those two steps, what you're going to do, if you've gone through and built your objects, so let's say we've built a car object, a bus object, and a truck object, somewhere along the way, we built constructors for those. We built, and probably, constructors and potentially destructors, so that we could build an instance of a car. Well, what you want to do with the factory is you're going to actually set those up in a way, and usually you're going to do it through, like being private classes and having some interfaces, things like that, where the constructor now for like the car, the bus, or the truck is not accessible anywhere other than through the factory. So you can't directly call those anymore. You lock it down so you can't call it, and that forces the factory to actually be where you're going to create that object. This is really important when you want to do things like There's other ways to do it, but it makes it a real good way if you want to keep track of the number of instances you have. If you want to do, sometimes it works for caching type stuff. So if you want to only create a new object if you need a new object, or if you have object pools, sometimes that works for a factory as well. Iterator. This is another one that's done a lot. I don't think it's one of those, I think actually people don't, these days you use it so much you don't realize that actually started as a pattern, because it's, as it says, it's a common pattern for traversing a collection. So pretty much anywhere you go, in whatever language, whatever environment, somewhere along the way you're going to have to traverse a collection. It is what it is. That's something we come across all the time. And you find that there's iterators built into just about every language out there. And basically all you do with an iterator, so you've seen them in action, all you do is you provide an interface to create or retrieve an iterator for the collection. So it's not the whole collection, it's just something that, it's basically, you don't want the whole collection, you don't want to move that all around, but the way an iterator works is you want it to be able to have enough information that when you apply it to a collection, you know which item it's on, and it probably needs to have a concept of like, previous and next. Maybe some more, maybe a little bit more, but essentially that, so you can traverse it. Worst case, you at least need to be able to know what you had traversed, and have a point to continue your traversal. Then you just design an iterator class. Once you've got that, you design your iterator class so it encapsulates traversal. So somehow, whatever that information is that it's holding that tells it where it is in the collection, it's also got to have some pieces to allow you to move through the collection. Typical iterator methods you're going to need are things like first, last, like you may jump to beginning, jump to end, next, previous, are you done, get the current item, something along those lines. Iterators are not, usually iterators are just are forward only. You can do them, both ways. So you can do them so that you can go forward and backward. It's just typically the whole idea of an iterator is to just quickly traverse all the way through a collection and not actually bounce back and forth within it. So if you're thinking, it's essentially like reading in a file, iterator is perfect for that, because you're just going to read a line, read a line, read a line, read a line, read a line. You're never going to actually go backwards through the file. And that's what the goal of an iterator is as well. And ideally, it provides the fastest way for you to actually traverse through that collection. And note, by the way, with the iterator, that it's not actually doing anything to that collection. All it's doing is traversing, and it allows you to, ideally, it allows you to actually pull whatever current item you are, return that so you can actually manipulate that item. Sometimes you'll be able to put it back in, but typically it's a read-only kind of thing, and allows you to pull an object out, and you'd have to otherwise adjust the collection later. Flyweights. Flyweights are not used near as often as they should be in a lot of larger systems. You do see it sometimes, database type stuff. Object relational mappers will use them for caching and just-in-time lazy loading, things like that. And that's really what a flyweight is for. Its goal for large systems is to reduce memory requirements, is reduce the amount of stuff that you have to have in memory and pass around. The way you build a flyweight is you look at the object that you're considering and see if it needs attention and whether the client class can handle the restructure. By that is, do you have a whole bunch of properties? And if so, are there properties that you don't normally really need? And with most cases, that's true for almost everything. You need, for a lot of classes, all you really need is an ID, and maybe like a description or a name or something like that, so you can do lists of it real quickly. The rest of the information you don't need. You don't need to pass that around. If you think of just a normal, like a user, which is normally going to be an ID, first name, last name, password, login, maybe some descriptive text, maybe there's some sort of avatar type picture. some special display name. You don't need all of that. Normally, if you're passing those, a list of users or users around, you need the ID and maybe like the last name so that you can display it in a list. The rest of stuff you don't need until you actually want to, like go grab, like say they've got an address. I don't need that address until I actually say, view the address. Then you would have to actually, pull it out. So you could have a flyweight. In that case, if you don't need a name, you get a flyweight that's just an ID. And then, once you click on it and view or whatever you would do it, then you go ahead and pull out the full, fill out the full class. So you divide the target class into shareable and non-shareable states, which is exactly that. So it'd be like ID, name, everything else. Create a factory that can cache and reuse the class instances. This is a perfect example right here of using a factory, because what you're going to do is you're not going to actually create the class. So if you have like parent and fly, let's call it these two, those are the two, or let's call it big and fly. You have these two classes. Well, you don't want to be able to directly instantiate either of them because of the way the flyweight works. You want to only, it's basically just-in-time data retrieval. So create a factory, say that you want the class. It's going to always give you fly first unless something comes in, and unless you've got something that says I need the address information. Maybe it's like I've got create factory and I've got create object, but I've got create object with address. Or you may even embed it in the class itself so that the fly, you have the fly initially, and it's got all of these methods on there that are really thin. And instead of like getters, it's basically says, all right, he said get, I don't have this value, so I've got to go swap myself out with a big and then pass the big back and do the get. So there's some things, and you could do it, so it's developer defined, so they could do something like full load or something like that that says, go give me the big, the full object, or you can do it beneath this, underneath the sheet so that all they know is that they're getting a value. And sometimes it has to go in and replace itself with a big value. Sometimes it doesn't. Maybe it's already got it. You can get really nasty and you could actually do it on an attribute by attribute basis so that you just leave everything null until somebody pulls it. And then if they do, if they say get, then you say, oh, well, I'm going to go look it up. But that becomes probably a lot of back and forth to your database or whatever your data source is. So the client or a third party must look up or compute the non-shareable data. So this is where you've got to have some way to get to that data that's that's being either not shared or or is being essentially kept from the live memory. And then you need to add the ability to add non-shareable state and supply it to the shareable message. So you start from the big object, you create the fly. He's going to have the core objects, the core attributes that you have to keep, and then you're going to have to walk through and set it up so that for those other attributes in the fly, he can access it. He can go pull a big object out and get those attributes. And all of these, they have, I do want to mention with all of these examples that we're going through, we're given the very generic approach to it. Just about every major language, especially object-oriented languages, you can probably find a solution. So if you did like adapter pattern Java example, you will find some examples of how to do it. They'll walk you through all the peculiarities of the language and how to get it done. So definitely, if you want to use any of these and they're confusing to you in any way, there are definitely examples all over the internet. So adapter, this converts one interface to another. This is really just the software version of any physical adapter you see. So if you've got, on your iPhone, if you've got an adapter that allows you to, like go from the USB-C to USB, that's an adapter. Software works the same way. In the way of case of a software adapter, you look at the players that are involved, which is basically the two ends of the adapter piece, identify the interface that is required. So these two have to somehow talk to one thing. So for the iPhone, that's actually, that adapter probably is just something along the lines of like, power in, power out, or something like that would be the interface. If it's something more complicated, then you may have, the equivalent of, like say multiple wires going into an adapter and then coming into a plug. Well, those things all have to be, coded out as part of the interface. You design a wrapper class to match the interface. So basically, when you think about it, you've got this internal, like if you think of any plug, basically any plug is an adapter. Within that plug, you've got all these wires that are connecting to stuff. And around those, you have this wrapper class, which is basically to turn it into a plug. The wrapper has an instance of the adaptees, and it maps the client interface to the adaptee. So typically the way you think of an adapter is you have sort of like a master and a child, or a master and a user. So the master has got essentially one interface that it has to deal with. For example, let's say you've got a application that only reads in, the only way you can bring in data is through XML. Well, maybe you do a CSV adapter, and what it does is it says, so it's going to convert it to XML, but in your CSV adapter, it's going to actually take a CSV file, it's going to do some stuff, and it's going to spit out XML. So in that case, the XML comes into that one interface. The adapter allows you to take something separate. In that case, you would have adapters for maybe, let's say you do an XML, well, maybe you've got an adapter for CSV, you've got an adapter for JSON, you've got another adapter for fixed width. And that's all it does, is it just maps, it's just a mapper. It just maps data from, the adaptee to the master. And then the client, the child there, they just utilize the adapter to couple them to the new interface, which is, that master interface. Singletons. Singletons are actually another one that fairly commonly used. I don't know that they're called that as much. I think it's another one that some people use it and they don't realize it. And the way singleton is very simple. It's just a class that you've ensured that there is only one instance at a time, and typically it's going to be globally accessible. You may want to pass it around, but typically singletons there's just one of them in one instance, and anywhere in the application it can be accessed. We do singletons really pretty easy. You define a private static attribute in the singleton. You define a public static accessor, and you do lazy initialization in the accessor. So what happens is, so if my singleton is bucket, when I do the constructor so bucket within itself is going to have a private instance of a bucket. It's going to have it, so it's sort of self-referencing. That's going to be, if it's allowed, depending on how it's set up, it's going to be static. So it's going to be at the class level, not at the instance level. Otherwise, you'll have to do something to count instances or something like that, or see if it's to see if an instance already been created. If you do, however it does it, if the instance already created, you pass the instance back anytime anybody wants to deal with it. So it's not where a constructor as much of as it is sort of an accessor or a copier. So if I say bucket.new, instead of it actually giving me a new bucket, it's going to give me that one instance. The case is you want to make sure that instance can never be, if somebody does bucket new again, it better point to the exact same instance. It can't be a copy of the instance. If it doesn't exist, so if they haven't called bucket.new before, at that point it creates one instance, puts it on its hook, basically it says this is my one instance, and then returns a pointer basically returns a pointer to that one instance that exists. The key to this is just make sure that all the constructors have got to be protected or private. You cannot allow any public constructors, because then it's easy enough for them to break it. They can override it and break it. And so clients can only use the accessor. So because you don't have a public constructor, the only way to get to it is via the accessor. This happens a lot. Java uses a whole bunch, and you'll find that sometimes in the Java API where it says, like for example, calendar is one that it'll say you can't do a new calendar. You have to do like calendar.getInstance because it's a singleton. And that's a good example of it. Singletons typically are going to be caching data that doesn't change anywhere else in the app, that you definitely don't want to change anywhere else in the app. and maybe even some app level stuff. So maybe things like number of users or something like that. There may be something there that's tracked that is global data that you don't want it messed with other than through the defined interfaces. Builders. It's somewhat similar. Builders somewhat similar to strategies. And basically what you do with the builder, instead of doing a task like just do it, the way a builder is set up is it allows you to do it a step at a time. So instead of just document.print, a builder would be you would actually say like send the document to builder and then tell it to print. And underneath that with the builder, it's going to take solving the problem of potentially many outputs. If that's really if that's your issue, if you've got one input but you've got multiple outputs, multiple approaches, that's great for a builder. You're going to encapsulate the parsing of the input into a reader. So you're going to have something, like I said, so it would be, like document printer dot print. Well, that's going to be where it's going to parse the input. So it's going to send something into it. You have a builder for each of the steps. So this is thinking definitely along the lines of batch type stuff. If you look at Spring Batch, that's actually, in a way, it's a series of builders, or it is a builder. It's a series of steps. And that's really how it's, what your goal is for this, is that you're going to read in your data, you're going to give it a builder, and then within the reader, he's going to start calling the builder, and he's going to actually start building this stuff out. Nice thing about a builder is that it allows you to swap in and out steps as you need to, depending on what the data is. There may be some stuff that you need, through any process. Like, for example, if you're printing a document, you may or may not need to print out a temporary version of it to do some work on it. You also are allowed to do this. This allows you to do several steps and treat them as a single transaction. So, for example, if you're going in and you're saving some data, and then you're writing some other stuff out, and then you're modifying some stuff, well, what you can do within a builder is you can have it be watching as it goes through the steps, and if at any point where it fails, you could have reversal steps essentially that says, okay, I failed. I'm going to walk through the fix it steps in order, in the right order, to get everything back to where, so I make no changes, and now I can kick it back to the user and say, oh, it failed. So builders are awesome for those kind of taking a lot of steps and turning them into a single transaction. Commands, it's just a request. This encapsulates just a request, exactly as you would think from the name. It's just a command. And this would be similar-ish to builders. But really what you're looking at here is, the key here is that you're doing you've got a single command, and it sort of applies it to everywhere. There's, like, if you think of print, you could do print if you want to do printing everywhere, all your objects, if you want that to always be a part of it, you could have like a root object that everybody inherits from. Think about it, and then you could have print up at the root, and everybody would implement their print. Well, if you treat it as a command, instead what you're able to do is you have that print encapsulated by itself, and then you just either pass it something, or more often than you just have you have an object that can call that command. So now you're able to encapsulate just the functionality like of print, and then pass that thing around instead of having it on each of the classes. And if you get large hierarchies, this becomes really important, because then you don't have these methods that have been inherited down through a whole bunch of different stuff. And there's the flexibility, because now I don't have to change my hierarchy at all if I suddenly decide, oh, wait, I want to go put a print for this other thing that's not in my primary hierarchy. And then, as it says towards the bottom there, every time you do it, you're just going to instantiate the command. You pass the command object from the sender to the receiver, and then the receiver decides when to execute. So it's basically like if I want to do print document, I would create a print. I'm going to go with that print. I'm going to assign it the document. And then whatever the receiver happens to be, like it may be printer, it may be laser printer, it may be file writer, whatever it is, I'm going to send print document to that thing, and then it gets executed whenever it feels like it. And it could be immediately, it could be not. So it could be, that's also a great way to queue stuff up. If you've got a big queue of objects and you've got some commands tied to each of those, then it's easy to work through that queue, and now that command is tied to it without having to do some sort of like dynamic coding or something like that, or reflection. Interpreters. These tend to be a little more complicated. And this is basically given a language, define a representation for its language. And what you want to do with an interpreter is decide if your little language is even worth the effort. Your little language may just be the numbers 1 through 10. It may be something that just says, so if I have a value of 1, I need to go do this. If I have a value 2, I need to do this other thing. If I have a value 3, do the third thing. Define a grammar for the language, which I just did. It's the numbers 1 through 10. But it could be more complicated. It could be a full-blown scripting language, like JavaScript or something like that. Map each production in the grammar to a class. So each of those items that exist, like in this case, 1 through 10, each of those are going to have a class. You organize those into some sort of a composite. So there's going to be some sort of like translator object or something along those lines. You're going to define an interpret method of some sort within there. So like if you have, like processor, you're going to have processor.interpret, because it's going to be able to bring in whatever your information is, and then with that start, essentially tokenizing it. The context is going to encapsulate the current state as input is parsed and output is accumulated. So it's that context that you've got, that parser that you've got, is taking in some information, and it's keeping all the state and keeping up with everything it's doing, and then spits out the output at the end. Because it could spit out the output as it goes, but that's really driving the interpretation process. All right, it's gotten through our 10. There are definitely more. These are really some of the more common patterns. There are a few others out there that you may have come across a lot, but there's many more that have been defined. I definitely recommend, for example, search for software design patterns. You're going to see a bunch of different sites. All of them are going to be like, a few patterns here, a few patterns there. The original Gang of 4 book has been updated and redone, and new people have added on top of it over the years. So if you're into a reading point of view, it's an awesome reference book to have, or grab one of the newer versions of it. And those have much more detail than what I've gotten into of what the patterns are and how they're used and what kind of problems they can solve. And I think they even have some like some gotchas and some things to watch out for. But definitely those sites are always changing, and it's a great way to go see what kind of patterns are out there, because you may stumble across one where you're like, oh, that's exactly what I need to solve whatever problem I'm going into. For example, if I've got a problem of I need to go crawl a website, there's probably I'm pretty sure it's called crawler, but I think there's a crawler pattern out there as well, or something like it, I bet. As I've noted before, all of these things were language agnostic. They had nothing to do with, Java or C# or PHP or Python or you name it. None of that. So you could probably do these patterns in any language. You can do them in C. You could do them in shell script, probably, whatever you want to do. It's just anything that supports the idea of probably structures, preferably classes. So an object-oriented language is always going to be the easier way to deal with patterns, to implement them. When you do your search, like I said, go ahead and tack a language on top of it, and you will see patterns that are language specific. And this is sometimes useful because there are things that are already in the languages. There are patterns built into modern languages all over the place. So there's a lot of it you don't actually have to do it yourself. You know, like I said, iterators, you don't have to build an iterator anywhere. Everything's built into how to do that. Sorting, you know, some of those kinds of things. That stuff's been done for you. So don't reinvent the wheel. And that brings us to this portion of it. Again, thanks for the time. Send any questions, comments, requests, any of that good stuff to info@developerpreneur. You can check out the site. You can contact us on the site. You can go find this on the site or out on Vimeo. If you have any questions about them, glad to help you, or either answer the questions or direct you to somebody that is more knowledgeable than ourselves and help you solve your problem. That wraps it up. So questions, comments?
Question. Which is the most pattern used, and what makes let me say developer say, look, today I'm gonna use MVC, or I'll use the Singleton pattern?
Well, those patterns they're all of those patterns. If you look back, it's basically like here, this top that top section there. Is basically defining, it's sort of like a problem definition. And so it's, that's the thing about wanting to, where it's very useful for you to sort of know what patterns are out there. Because if you're familiar with the patterns and you're familiar with the kinds of problems that patterns can solve, then when you run into that problem in your coding, you're like, oh, this sounds like something that's been solved in a pattern, and you can go do a little bit of search and find a pattern and say, oh, that's right, this would help me quite a bit. And then, that's how so it's the problem you're solving is what defines which pattern you want to use, really.
And in some cases, you don't necessarily stick to one pattern for an entire application.
Okay.
Because, for example, like within my test builder, my test framework, I've got builders, I've got, I'll have an MVC layer. I mean, there's multiple layers. It just depends on the complexity of the application you're working on.
Yeah, most patterns are not at the software, they're not at the application level, they're down in the code level. So just like you could have tons of classes and objects, you could have tons of patterns that you're using.
Yeah, because I use factories a lot. It makes it easy to distinguish if you have like lots of builders. So you could create a factory builder. So you could essentially call a factory and say, for example, build login page or get login page data. So I have builders for building my spreadsheet data. I have builders for building my database data. When I worked at Northrop Grumman, we had builders to convert web service calls from the government to build them into message beans to then put them out into a message queue. So there are many different ways of applying these patterns. Again, you really just kind of have to step back and look at what you're trying to do, and then kind of, I don't know if you find this anymore, Rob, but I guess maybe it's just because I've been doing this so long, but I just typically fall into a particular pattern based on what I'm trying to do. I really don't think about it much anymore once I'm in there. I mean, once a project's built, but to even build a project from scratch anymore, I mean, you start out with some of the basics, but it's very quickly, it's like, oh, well, this could be a factory. Oh, this could be managed by this. I guess it just comes with experience, and over time, you just don't think about it anymore. You just start doing it.
Yeah, definitely. I don't think that's, I mean, that's sort of the goal with all this, is that you get to a point where you're just cranking out, patterns all the time. You're not, these are all things that have been solved before. So then that means there's no reason for you to do it yourself. There's no reason for you to reinvent the wheel. You just go in and you say, okay, I'm doing, X. I know I've done this before. This is an easy way to do it. So I'm going to go ahead and do it and, implement the pattern, and then you're just going. I think there's a certain point where you just don't think about it. You just get, and that's the whole goal of them, is to just be comfortable with the pattern itself and how to use it.
Right. I mean, I guess early on, like at the very beginning of a project, you would think about patterns a little bit just to kind of get started. But once you're started, I mean, there's really more to the design and the architecture of the whole application at that point. But typically, you'll fall into the type of pattern you'll want to use pretty quickly, like MVC, standalone, at least at the base. And then as you start breaking out into smaller and smaller components and pieces, then other patterns just kind of by default just start dropping into place.
Well, that's another thing is there's some patterns are solution level, like MVC. Some are very granular level, like a command or iterators. Some of these you're going to fall into using them. They're not you've designed your application. They really don't have anything to do necessarily with the design. They're down to the implementation. So as you're going through and you're building either a system, a subsystem, or system or subsystem, or even methods, down to methods within a class, then you may be embracing different patterns along the way. Like I said, it all comes down to what problem are you solving, what's the scope of it, and then you dive it in and doing it. And it goes back to, if you're comfortable with patterns, if you're using patterns a lot, then you're going to be more likely to either just know them or and just know them and implement them as you go, or at least know that they're out there and say, there's this thing I'm doing. I bet there's an easier way to do it than me reinventing the wheel, which is really the hard. I mean, that's with experienced developers, that's really what they do best, is they don't reinvent the wheel. They've already done it before. They know how to do it, or they know somebody that's done it and they know how to get have access to that. So they're not having to constantly solve new problems. There's a bunch of solved problems that they get to just sort of like apply code to it, and then you move on to the next piece. You move on to the stuff that's either not been solved or that is more complex, or just integrate your solutions.
Now, what about anti-patterns? Have you ever really dealt much with those? I have a little bit, but I just find it hard to really apply them in many situations.
Anti-patterns are awesome for code reviews and things like that. They're actually pretty good at the front end too. When you're doing design, it doesn't hurt to sort of flip through, look at what kind of anti-patterns are out there. So anti-patterns, for those that don't know, are really where patterns are best practices and way to do things. Anti-patterns are definitely ways to not do something. Anti-patterns are things where if you do this, you're going to end up, painting yourself in a corner, or you're going to end up with an unstable system or whatever. It's something bad is going to happen. So if it's similar to patterns, if you know anti-patterns, if you're comfortable with them, you have even just basic knowledge of them, they're going to help you just sort of this is what's not to do, what not to do. So if you find yourself going down a certain trail and suddenly you're like, oh crap, this sounds like an anti-pattern, then you can go, say, oh wait, I don't want to do that. I remember this being so, and if you don't have to know specifically, because you may want to look at it and say, okay, with this anti-pattern, if we do this approach, then this is what the bad stuff is going to be. This is what the output's going to be that we may not want. Now, that doesn't mean that you don't follow through anyways. It may be something where you say, well, I know, but that's really, I've got to do this. I've got to go this way, but at least the anti-pattern tells you, it basically gives you some warning on what to look out for. And so here's some things we're going to have to do to correct for whatever the badness of the anti-pattern is. I've thought about, I was going to do this topic, patterns and anti-patterns, but it got too big too quick. So I said, well, I may come back at some point and look at anti-patterns. I think it actually would not be a bad thing to do, because anti-patterns tend to be, my experience, anti-patterns are more like full-blown solution level. They're not down at you don't have like the anti-pattern equivalent of an iterator or command. They're up at like MVC and stuff like that. So I think it would be an interesting discussion at some point time to go through some common anti-patterns. And there is like a first there was like a first anti-patterns book, sort of like it was along the same lines of like the world's ugliest websites or some of those kinds of things where they're all about what not to do. Like I said, I think they're worth a discussion at some point. It was going to be too much for this topic.